out there. We'll go back out there and try for another launch. Mike will lay out for you what we have in between. I'll say this, obviously, we've talked about this mission being risky, but we're going to take the risks that make sense. The risk that we know that have already pushed the vehicle and the system as far as it will when we launch, and be ready to go at that time. So with that, let me turn it over to Mike for some more specifics.
Okay, and good afternoon again. Thank you for continuing to follow the Artemis 1 mission in our program. I'll just briefly recap where we left off the last time we were here, which was after the Launch -2 mission management team meeting on the 1st to review our readiness to head into this launch attempt. If you recall, the launch operations team out of the Launch Control Center stayed in the launch countdown following the attempt on Monday, and that gave us a head start headed into today's attempt. The team, when we came in for the tanking meeting, which was to decide whether or not to load the vehicle with the cryogenic fuel and oxidizer today, was on the timeline or slightly ahead, and it was a clean meeting. We met at 04:45 this morning, and we talked about our setup for the day, and there were a few items that we talked about, but most of those were of no particular constraint relative to setting up for our launch attempt. The team identified that they had 46 collision, and it was a clean meeting. We met at 04:45 this morning. We do have, at this particular time of year, a high propellant bulk temperature, which gives us more performance out of the rocket. So essentially, we have a hot rocket in terms of the performance to launch, and that actually, as we fly up through the Earth's atmosphere, pushes the higher end of the maximum dynamic pressure, or Q bar. And we saw that we had positive margins, but lower margins on one specific area on the Orion spacecraft, and we were watching that. The vehicle was expected to get to about 700 pounds per square foot of pressure as it headed up through the period of maximum dynamic pressure. Just prior to the cryogenic loading operation, the team was working through a chill down, and there was an inadvertent pressurization of the hydrogen transfer line, that the pressure exceeded what we had planned, which was about 20 pounds per square inch. It got up to about 60 pounds per square inch. And the flight hardware itself, we know, is fine. We did not exceed the maximum design pressure, but there's a chance that the soft goods, or the seal in the quick disconnect at the 8-inch quick disconnect, saw some effects from that. But it's too early to tell exactly whether that was the cause of the hydrogen leak that we had today. What we do know is that we saw a large leak at the 8-inch quick disconnect today, and that leak started when we went from the slow fill to the fast fill. This particular quick disconnect did not have a problem of this magnitude on Monday. We did see a small leak, but we did not see one of this magnitude. It was characterized as a large leak by our operations team. The team tried 3 times to resolve the leak, and all 3 times we saw a large leak. And as was discussed previously, if you can thermally stabilize both sides of that quick disconnect, we have a ground side and a flight side, and that is where the fluid flow occurs through. If you can chill that down and ensure that there's no differential temperature across that interface, sometimes the leaks can seal themselves or heal themselves. So the team attempted that. They attempted to essentially reseat the leak by increasing the pressure in there, and that was not successful. So initially, the team declared the scrub at 11:17 Eastern time, and then went into vehicle safing and drained the cryo. The liquid oxygen is currently off the vehicle, and the liquid hydrogen, at least when we were in the mission management team meeting, was still on board the vehicle, and they were in the process of draining it. It should be off by now, or very close to it. The team will get into what they call the inerting, which is they put gaseous nitrogen in there so as not to condense water vapor in the tank area, and then they'll swap over to air. What that does is it allows us to get the tanks back up to ambient conditions, and then for us to gain access. In the scrub meeting that we had at 2:30 Eastern, we talked about 3 options. The first option was to simply demate and remate the umbilical at the pad, hoping that the soft goods would seal the leak up, but our confidence level, given the size of the leak that we saw today, was fairly low, that would solve the problem. The team leaned towards a removal and replacement of the soft goods in the quick disconnect, and the options were basically to do it at the pad or do it back in the vehicle assembly building. And either of those options do not preserve our ability to fly before the end of this launch period, which expires on the 6th. So the team is developing a series of schedule options, and we're going to hear about those early next week. The schedule options include removal and replacement of the soft goods on the quick disconnect at the pad, followed by a cryo test. That is the only place we can get a full cryo test to ensure that we do not have a further issue with respect to leaks at the temperatures that we need to fill the vehicle on day of launch. The other option is to roll back and remove and replace the quick disconnect soft goods in the vehicle assembly building. There's a risk versus risk trade. Doing it at the pad, you're exposed to the environmental conditions, and we need to build an environmental enclosure to do that. If we do it in the vehicle assembly building, the vehicle assembly building is the environmental enclosure. However, we cannot test this quick disconnect in the VAB at cryogenic temperatures. We can only do it at ambient temperatures. So we're working through those options. The team, it's too early to say, but they're working through a fault tree analysis as to why we did not see a leak of this magnitude on Monday, but we're seeing it of this magnitude at today's attempt. And they're also looking at the chill down procedure to look at additional controls such that we don't have a reoccurrence of the inadvertent overpressure that we had earlier today. So all that said, we've talked about it before. This is an incredibly hard business. This is an initial test flight of this vehicle. As was said by Administrator Nelson, we're going to fly when we're ready. And as part of this initial test flight, we're learning the vehicle. We're learning how to operate the vehicle, and we are learning all of the things required to get us ready to fly. And we've demonstrated a large number of those things, not only through wet dress and some of the other ground tests that we've had, but we are still learning as we go, again, to get this vehicle off safely. So our focus is on understanding the problem, developing solutions in terms of schedule, but also risk versus risk impacts, and we'll follow up next week when we have those options fleshed out further. So with that, I'll pass it back to Jackie.
Thanks, Mike. So now we'll open it up for questions in the room and also on the phones. On the phones, as a reminder, press *1 to get into the queue. And in the room, if you could leave your hand high for the mic folks to come get you after you ask your question. First up, Joey Roulette with Reuters.
Question for Mike. If you decide to roll back, and I know it's uncertain right now, what's the quickest you could roll SLS back out to the pad? What would that look like, and what other things would you have to do in the VAB while it's there?
We're looking at several weeks to do that, depending on the required work at the pad or whether we do it in the vehicle assembly building. That'll determine the exact schedule, but it's several weeks of work. It's really too early to say exactly how many days.
Thanks. And up next on the phones, we have Marcia Dunn with the AP.
Yes, hi, can you hear me?
We can hear you.
Yes. I was wondering, so are you saying if you do the repairs at the pad and it seems to go well, you could still maybe get off in September by the end of the month before the SpaceX launch coming up at the beginning of October? Is that a possibility? And the way things stand right now, which way do you think you're leaning for? Thanks.
I'll just take the first part of that. I think we still have our constraint on the range, with the range to test our flight termination system, which is right now we have 25 days. I think we're going to talk with the range about what the possibilities are. But in order to test our batteries, change out the batteries, we have to roll back for that. And I'll let you handle the options.
Yeah, and Marcia, with respect to whether or not September, the latter part of September is still in the trade space, I think it's too early to tell. It really comes down to what does the fault tree analysis tell us, and what are the necessary changes and mitigations required in order to have a confidence that we've resolved this large leak at the 8-inch quick disconnect. So I think we'll have a much better answer early next week, and right now it's just too early to tell.
Thank you. Next, we have Tom Costello with NBC.
Hi, good afternoon. Can I just clarify, you said that the line had been overpressurized up to 60 psi. Do you believe that overpressurization potentially caused the leak that then you were dealing with all day today? And any idea how that line was overpressurized?
Yeah, I guess what I'd say is I think Mike talked about the fault tree. We have to go look at, is that a cause? Is that the cause? I'm sure it'll end up on the fault tree, but we have to run through all legs of that fault tree before we decide that's absolutely the cause. We do, I think, I forget how the words that you used the last one. We kind of tune in this hydrogen. We did that on Monday. Monday we saw it start to go up, and we slowed the rate and did a manual fill. That's just part of the process, and we need to look, as Mike said, to automate that and get the places where it'll cut out if the pressure is going too high, so we don't hit that kind of command again. That'll be part of what we automate and practice for the next time. But it's on the fault tree. It's kind of tough to say right now, yeah, that is the absolute cause.
Chris Davenport with the Washington Post. Oh.
Thank you. I just want to clarify, you're going back to the VAB no matter what, right? I just want to clarify that. And I wonder if you could just briefly, Mike, talk about the differences with this hydrogen leak, this big one that you had, versus the one that you were able to overcome on Monday. Thanks.
Yeah, for the VAB part of it, it's what I said. We have to go back right now. We do not have an agreement with the range that we can launch when our batteries have not been tested after 25 days. So that runs out here, as Mike said. And so in order to change them out, we have to go back. To get that kind of extension with the range is something we'd have to talk to them about. So right now our position is we will have to go back to the VAB. When we go back will depend on the testing options that Mike talked about.
Yeah, and to take a crack at the second part of your question there, Chris, in terms of the leak that we saw on Monday, it was a manageable leak. This was not a manageable leak. As soon as we started to get into fast fill, and we need to get into fast fill, again, as part of this delicate balance of you want to you want to load within the capability of the quick disconnect, which tells you want to slow it down, but you also want to speed it up so you can make your launch window. So you've got this balance between the flow rate and the pressure, and if there's a leak present, you need to manage that. So on Monday, the team was able to successfully work their way through that while staying below the hazardous concentration limit of the hydrogen that was leaking out. We were unable to do that today. It was a much larger leak. The team tried to work and use the same technique as part of a pre-planned procedure. They tried multiple times, and that didn't work, in addition to trying to bump the quick disconnect and try to reseat it, and none of those techniques worked.